Hello and welcome to this video on PostgreSQL exemplified read-through. We had covered till pattern matching in last video, and now in this video we are going to cover data type formatting functions. It will take roughly two videos to cover this. So before we go into the theory and read through, let's look at an example. Okay. So let me open the file which I have prepared. This is called data formatting.sql. So I have some data which I have selected: timestamp as TS, date as D, an interval as IV, and a numeric as N. I select this function and I call it sample. And from this sample, we convert these four parameters: timestamp, date, interval, and numeric to various formats. For example, date is formatted to YYYYMMDD as ISO date, DD/MM/YYYY as European date, then we have US date, then long date. So don't worry about this formatting format specifier. This is called format specifier coming from. So similarly, we have year of 4 digits, 2 digits, and then we have year with comma, months and all. Okay. Then we convert timestamp to certain things in various formats. So this FF1, FF2, it will become clear once we look at the theory. Then we convert interval to hour, minute, second. We have the numeric format in various different formats. Okay. And we convert then certain dates to different formats, and we can actually look at something like backup underscore. We convert timestamp to another date format. We have invoiced and dated on date to some format. So let's look at this output of this function. Don't worry, I have not described anything yet. We are just looking at as an example that what formatting we can do. So what we do is we select all this to our so we select from here and we select still here. Commands we don't need to select, but now we log in to Postgres database and we paste this. Okay, and hit enter. So see, all the formatting output has come. So you can look at the different parts of the query and see why some output has come here. Okay. Now we will go and look at the description of this. So you can pause the video at different moments and look at the query and all that. So the crux of that SQL query or SQL query has come from this. Okay. So we are going to read through this functions. So let's start the read through. As I said, it will take probably 2 days because it's roughly 9 or 10 pages, I don't know. 279 to 270 to 279 looks like 9 pages. So let's get started. The PostgreSQL formatting functions provide a powerful set of tools for converting various data types: date, time, integer, floating point, numeric to formatted strings, and for converting from formatted strings to specific data types. Table 9.26 lists the functions. These functions all follow a common calling convention. The first argument is the value to be formatted, and second argument is a template that defines the output or input format. Let me look at the previous. Okay, it is recorded. So we have formatting functions. We have toChar, which takes a timestamp and formatting function, and output is text. Then we have timestamp with time zone, and output is text. So this is HH12 means hour in 12-hour format. So 17-hour is getting converted to 05. MI stands for minutes, so minute is 31. And SS is second, so we have got this second here. Then we have 2-char interval to text, similarly 2-char numeric type to text, and we have to date from text to text, to number text to text, and it gives the numeric. Here we get date. To timestamp, we take two text arguments and timestamp timestamp will be returned. So we will now look at the rules that how these are getting converted. Two timestamp and two date exist to handle input formats that cannot be converted by simply casting. For most standard datetime formats, simply casting the source string to the required data type works and is much easier. Similarly, two number is unnecessary for standard numeric representations. In a 2-char output template string, there are certain patterns that are recognized and replaced with appropriately formatted data based on the given value. Any text that is not a template pattern is simply copied by the template. Similarly, in an input template string for the other functions, template patterns identify the value to be supplied by the input data string. If there are characters in the template string that are not template patterns, the corresponding characters in the input data string are simply skipped over, whether or not they are equal to the template string characters. Now, this table shows us the template patterns for formatting date and time values. So HH is 12-hour day. HH is 12-hour day. HH12 is also 12-hour day. Just that it is for both. HH22 is 0 to 24-hour format. MI for minute, SS for second, MS for millisecond, US for microsecond, FF1 is tenths of second, FF2 is hundredths of second, FF3 is millisecond, FF4 is tenths of a millisecond, FF5 is hundredths of a millisecond, FF6 is microsecond. Then we have SS, and SSS, which is seconds past midnight. So it will range between 0 to 86,399, as there are 86,400 seconds in a day. AM capital and small, PM capital and small dictates meridian indicator. A dot M dot small and capital, same for PM. It gives again meridian indicator. Y comma YYY is 4 digits of year with comma. YYYY is year, 4 or more digits. Then we have 3 digits, 2 digits, 1 digit. Then we have IYYY, which is also 8601 week numbering here, 4 or more digits. Similarly, we have IYY, IY, and I, which are all ISO digits. So these are last 3 and 2 1 digits. Then we have BC, small and capital, AD, small and capital, which is era indicator, and same with the periods. Then we have month, which is full uppercase month name. We have month with M capital and all small, full capitalized month name. All small is lowercase month name. MON is the abbreviated uppercase month name. And then we have capitalized and lowercase month names, 3 characters. Then we have MM, which is month number, day for full uppercase day name. Similarly, we have capitalized and small day names. We have DY, which is uppercase day name, abbreviated, and we have capitalized date, small date. We have DDD, which is date of year from 1 to 366 for leap year. Excuse me. We have IDDD, which is day of ISO 8601 week numbering year. Day 1 of the year is Monday of the first ISO week. DD is day of month, 0 to 31, 1 to 31. Capital D is day of week, Sunday to Saturday. ID is ISO 8601 day of the week, Monday to Sunday. So notice the difference. The normal weeks go from Sunday to Saturday, but ISO weeks go from Monday to Sunday. We have W, which is week of month, 1 to 5. And WW is week number of year. IW is week number of ISO 8601. CC is century, 2 digits. And J is billion date. Integer date since 24th November 4714 BC. Q is quarter, RM is Roman numerals, month in uppercase Roman numerals. I, for example, this is month in Roman numerals. RM is month in lowercase Roman numerals. TZ is uppercase time zone abbreviation. Small tz is lowercase. TZH is time zone hours. TZ minute is time zone minutes. Off is time zone offset from UTC. Now these are the form specifiers. Modifiers can be applied to any template pattern to alter its behavior. For example, FM month is the month pattern with the FM modifier. Now we have modifier patterns for datetime formatting. FM prefix is fill mode, suppress leading zeros and padding blanks. PH suffix is uppercase ordinal number suffix. The small t suffix is lowercase, capital FX is fixed, format global option. PM prefix is transition mode, use localized day and month times based on LCM score time. We have SP suffix, which is not implemented. Now we have the usage notes for formatting. FM suppresses leading zeros and fading blanks that would otherwise be added to make the output of a pattern be fixed. In PostgreSQL, FM modifies only the next specification, while in Oracle, FM affects all subsequent specifications, and repeated FM modifiers toggle fill mode on and off. PM suppresses trailing blanks whether or not FM is specified. To underscore timestamp and to underscore date ignore letter case in the input. So for example, capital month, capitalized month and lowercase month all accept the same string. When using the TM modifier, case folding is done according to the rules of the function's interpolation. To underscore timestamp and to underscore date skip multiple blank spaces at the beginning of the input string and around date and time value until the FX option is used. For example, to underscore timestamp space 2000 more space June YY space month, and to underscore timestamp similar string with the different spacing is formatted work, but first one returns an error because to underscore timestamp expects only a single space. FX must be specified as the first item in the template. A separator, a space or non-letter or non-digit character in the template string of to underscore timestamp and to underscore date matches any single separator in the input string or is skipped unless the FX option is used. For example, we have 2000 June being formatted to YYYY//1 and to underscore timestamp. Now this time we have single slash over here and space over here work, but the timestamp / June YYYY/1 returns an error because the number of separators in the input string exceeds the number of separators in the template. If FX is specified as separator in the template string matches exactly one character in the input string. But note that the input string character is not required to be the same as the separator from the template string. For example, to underscore timestamp, we have this string and modifier works, but to timestamp, this returns an error because the second space in the template string consumes the letter J from the input string. So here this space, second space over here will consume the letter J from the input string. A TZH template pattern can match a signed number without the FX option. Minus sign may be ambiguous and could be interpreted as a separator. This ambiguity is resolved as follows. If the number of separators before TZH in the template string is less than the number of separators before the minus sign in the input string, the minus sign is interpreted as part of TZH. Otherwise, the minus sign is considered to be a separator between values. For example, to underscore timestamp 2000 space -10 YYYY minus TZH matches to -10. But to timestamp 2000 space -10 YYYY double space TZH matches 10 to TZH. Ordinary text is allowed in to underscore char templates and will be outputted literally. You can put a substring in double quotes to force it to be interpreted as literal text even if it contains template patterns. For example, in double quotes, hello year, space, double quotes, y. The y will be replaced by the year data, but single y in the year will not be. And to date or to number or times to timestamp literal text and double quoted strings result in skipping the number of characters contained in the string. For example, excess skips two input characters, whether or not they are excess. Now we have a tip. Prior to PostgreSQL call, it was possible to skip arbitrary text in the input string using non-letter or non-digit characters. For example, to underscore timestamp 2000 y6 m1d y minus minus dd used to work. Now you can only use letter characters for this purpose. For example, to underscore timestamp this input string with just template string, and to underscore timestamp will skip m and y and m and d. So the question is why it is skipping y, m and d. So let's look at that. So we have y here, so it will match the year, and then we have t, okay, which will match y, and then we have 6m, which will match mm, and then we have t, which will match nothing, and d will finally match 1. So this t will be skipped. Okay. So here y, m and d small ones are in double quotes, so they are little strings. So how much is there? We won't be able to cover this. So let's see. If you want to have a double quote in the output, you must precede it with a backslash. For example, backslash double quotes y space month backslash double quotes. Backslashes are not otherwise special outside of double quoted strings. Within a double quoted string, the backslash causes the next character to be taken with challenge, whatever it is. But this is no special effects until the next character is a double quote or another backslash. In to underscore timestamp and to underscore date, if the year format specification is less than 4 digits, example y, and the supplied year is less than 4 digits, the year will be adjusted to be nearest to the year 2020. Example 95 becomes 1995. In to underscore timestamp and to underscore date, negative years are treated as signifying BC. If you write both a negative year and an explicit BC field, you get AD again. An input of year 0 is treated as 1 BC. So I think we can stop here. We won't be able to finish it. There is quite a bit of information here. So we will finish remaining stuff in the next video, right? So what we will do is we will stop here, and in the next video we will cover from here. Okay, I don't want to make too long a video, so I hope that you are enjoying this video, and if you have not watched the other videos in playlist, you should do so. There are lots of examples and lots of details from the documentation in this video. Also, there are lots of practical examples, so I'm providing a combination of theory and practical. So we'll continue this in the next video tomorrow, and we'll finish this tomorrow. So with this, I will end this video here, and I'll thank you for watching the video, and I hope that we are progressing very well in programming. So once we are done with PostgreSQL, we will continue our JavaScript and Python and REST videos, and we'll create web APIs and a bit of front end. I'm not a front end specialist, but I manage okay enough the front end part. The only thing which sucks for me on front end is the design, but I'm not a designer, so my designs are not very good. I can write CSS, but I'm not very good designer. So we will use all this knowledge to develop web applications. Okay, in JavaScript we will cover Express.js to begin with. First we will do Node.js, then we will do Express.js, and then we will do Nest.js. And in what you call in Python, we will start with Fast API, and then we'll proceed to Flask, and then Django. Maybe we can skip Django, but Django will do. It's a very popular framework, and lots of people use it. And Rust, we will start with XM and followed by FTX. So that is the plan. That is where PostgreSQL will be used. But actually, we will switch to Yugabyte DB, not to the PostgreSQL. That is, for example, I'll show you my setup. So, for example, if you look at my process table, this Postgres is Yugabyte. Okay. So if you locate Postgres, so all the Postgres where the user is Shiv is Gigabyte process. But if you see Postgres with Postgres user, that is the Postgres database. So I run both Postgres and Gigabyte. This Postgres is Gigabyte Postgres. So if you look at my computer and you look at install, we quickly install it. It won't take long. So it's not that I only talk about theory and I don't use it. I eat my own dog food. So what I say is what I do. Let me show you Gigabyte running. So you will see port 5433, and this is Postgres, and this is Gigabyte. Okay. You see Gigabyte server is running, several servers of Gigabyte are running, master and lots of other processes, and Postgres running as well. Okay. So with this, I will end this video here, and we will meet again tomorrow where we will complete the data formatting functions. So once again, thanks a lot for watching the video, and I'll take my leave. Should keep learning and enjoy, and have a nice day.